where what we did is we found a different way to show how these electrons all configured. So how something's put together. So here's aluminum. How are the electrons put together for aluminum? And so we went through, and some of you copied down where all these were located. So we always start at the inner shell. So inner shells, we're going to start talking about inner shells and outer shells, or inner levels and outer levels. Well, the outermost level is the one that is, when you start looking at the atom from the outside, it's the first energy level you get to. And so it would be the outermost level has 3 electrons in it. You guys see that? The outermost level. Now I put this extra ring in there, but there's no electrons there, so that's really non-existent at this point in time. For that level to exist, there has to be electrons there. But I put it there because I'm going to show farther out later on. Okay? So the outermost level is the 3rd level. It has 3 electrons in there. We're going to start talking about this thing called valence electrons, and they're the most important electrons in the behavior of the atom. We don't care about inner level electrons anymore. Okay? We don't care about the 2 in the first level and the 8 in the second level down the road. We will not care anything about those. We only care about the outer level electrons. Well, to get the outer level electrons right, we have to be able to put it together and configure it in the right way. Eventually, we're not going to show those electrons in any of what we're doing in the future. Okay? But we kind of have to have a ground level understanding of where these electrons are at. Okay? So what we did is we just said, okay, we're going to go ahead and identify these electrons. So these first 2 we identified as where they were at, right? So where are they at?
S.
Okay, they're in an S sublevel.
They're in the first level.
And they're in the first level.
And there's 2 of them.
And there's 2 of them. Does anybody not understand that abbreviation?
No. So
Kind of got that abbreviation. What we're doing is we're kind of using, we're going to get away from showing these drawings like this. But what we're doing is we're just showing where all these electrons are at and what sublevel character they have. Okay?
what did you use the different colors for, like the red?
I'll get to that here in a second. Okay? So then, that level is full. It only holds 2 electrons. We are at helium. So here's helium's configuration. So if you had to draw the electron configuration for helium, this is it. Any questions? So that'd be a nice one to have on the test.
Oh, yeah.
Right? You say, well, what's the electron configuration for helium? You say 1s2, you're done.
We should do that.
You might have one of those, easy ones. Got to have some easy ones on there. Next, okay? The next one we're going to look at are these 2 electrons here. And so those are the next to go in that we're going to describe. Those electrons are in what level?
P.
Second.
Dang it.
What sublevel are they in?
S.
S.
What?
Because it goes S.
Because every level starts
with S.
with the S.
Okay.
Okay? Because the first level has S's, second level has S's and P's.
Oh,
Third
so
level has
it's
S, P's, and D's.
So
They
that-
always start with the S's. So electrons always go to the S's first. That's the first place they'll go. Once those S's sublevel is filled within a level, then they have to go somewhere else. Okay, they can't stay. So there's 2 in there. So this is the electron configuration for beryllium.
Wow, crazy concept.
Here's beryllium. Okay, now you don't have to write each one of these down, okay, because I'm going to use them as a guide to kind of show how families work. Families are groups that are up and down. So families should have a lot of characteristics that are the same no matter where you're at on the periodic table or what element you're dealing with. Okay? So we'll see if we can try to prove that a little bit. These next 3 are in what sublevel?
P.
P. Okay, those all
They're
three
level
are in the P and they're full, but what level are they in?
2.
2P6. Any questions with that?
Why are those ones different than the ones on the top? I'm confused.
What do you mean, different color?
No, like.
Okay,
I don't know.
so Billy, this is what happens. These electrons have to go to these orbitals, all right?
Oh.
So every level has an S. Once the S is full, then it has to go to the next level, like between the 1 and 2, or it has to go to a different type of sublevel. It cannot continue to fill S's because there's only one S orbital in every level, period. So what's the next option for these electrons to go to? Well, once the S is filled in the second level, what other orbital sublevel is in the second level? P. So guess where they have to go?
P.
They have to go to the second level of P sublevel. They have to go there. And how many can the P's hold?
6.
6. Now, remember the periodic table. We're at boron through neon right now. So right now we're at neon. How many's across this P group? Remember I said this is a P
6.
block. 1, 2, 3, 4, 5, 6. So you're all the way to neon now. So here's neon. Okay? So, I'm going to write down the configuration for these. This is 1s2, this is 2s2 for beryllium. And then this one here is element neon. Okay? And it's, right here is neon. And it is 1s2, 2s2, 2p6. Okay, so we're at neon. All right, so this is neon. And this is helium. Okay, they're in the same family. Do you see anything characteristic-wise between neon and helium that allows you to kind of see that they're similar in some way?
Well, they both have their first level is with 2 electrons.
Right, but beryllium has the 2 there also, but it won't be in the same family. So is there something else?
It's always full.
It's full. So far, the first level helium is full. Neon is full. What do we know about the noble gases and their reactivity? They're what?
5.
No. Low. They're no activity. No reactivity. Okay? So, helium and neon, there's no reactivity. They're full. Kind of like on Thanksgiving. Do you want to eat any more once you're full?
Yeah.
Yeah, I do too. Okay? So, but normally you're not going to want to do that once you're full. Okay, so we'll leave it at that. So then we're still doing aluminum. We've got to show what are these 2 here? What are they?
S.
There?
3s.
3s2. So we're describing where every electron's at, what kind of shape they have, and then this last one here is what?
3P.
3p1. Any questions you guys have? Yes.
Do the S and the P, like, other than placeholder, does it stand for anything?
No.
Okay.
Wait, why is there 3? Oh, because it's the 3rd level. I got you.
Yep, because it's 3rd level.
And
Okay. All right. So now, what I want you guys to do, I want you to write out the electron configuration for argon.
Ooh.
That's a tricky
I
one.
did a presentation.
Go ahead. Now, it should be all the way the same until the 3s2, which would be calcium, right? Should be all the way the same through calcium. Not through calcium, I'm sorry. Through magnesium. Okay? You have 2 here, 2 here, and 2 here. That adds up to 18. These are all in what sublevel?
That is in the third.
They're the P's.
Sublevel. Yeah.
There's 3 of them. It'd be 3p6.
What? I don't understand how you got there.
Okay, so here's the progression. These electrons are looking, they're looking for a place to go. The first 2 electrons, where they go? 1s2. It is full.
Because they can only have 2 in the S sublevel.
And 2 in the first level.
Yeah.
Okay? 2 more electrons come along. Where do I go?
2 squared. The P.
Nope.
2 squared.
I go to the second level of S's. Why? Why the second level S's? Because the first level is full. There's S's and P's in the second level. Which one requires more energy, an S or a P? P. So where are they going to go? The 2S or the 2P? The 2S.
2S.
Because they're lower energy level. Okay, it's kind of like chores. I go home. What's the easiest chore? I take out the garbage. Compared to vacuum and dust everything in the living room. Okay? Walk the dog. Well, maybe that's higher on the list. Okay? Clean all the dishes. Put them away. That's maybe higher on the list. Which one would you choose? Take out the garbage. Okay, if that one's taken, I'm going to take the next easiest one. So, okay, I'm about through with this. Okay? So the next one, I go to 2S. I have some more come along. Where are they going to go?
The next easiest level.
The next easiest sub level. So it's going to be, where are they going to go? 2p6. Right?
Yeah.
Second level's full.
So now they have
Can't
to,
hold anymore. 8 is max.
they have to go to the third level.
You got to go to the third level. So what sub level needs to fill?
They start out with the S one.
Got to start with the easiest shape. 3s2. Now the s2 is filled. So what's the next possible? An electron comes along. What's the next possible place I can go?
The P sublevels.
The p's of the third level until they're full. Right now they're full. Okay. So here's helium. Here's neon. And here's argon. So we are at argon right now. Is that correct?
Yes.
So here's argon.
Really, don't say Carson.
So look at similarities between argon and neon. Do you guys see anything that's the same between the two?
The first 2 levels are filled.
Okay? Is this level, third level, filled for argon?
No, not all the way.
What's similarities between neon then and argon? They're in the same family. Yeah, they both end in 3p6. They both end in p6 would be one. What else do you see?
The 2 levels filled. I don't know. That's all I really see.
How many's in the outer level for both of them? 8.
Oh.
They both have 8.
So
So,
how do we look at this and know that it's argon? Well, you count
because you
the-
count them. 2,
the
4,
electrons.
6
It's 18.
is 10, plus 2 is 12, plus 6 is 18. You add them up. That's element number 18.
Otherwise known as.
So are they all going to start the same then? Once if it's a bigger one, they'll all have the same beginning then?
They all have the same beginning.
Okay.
Are we going to be able to use the periodic table?
Yep. Yep, you have to use the periodic. You have to use the periodic table. Okay, now here's the really tough one, okay? Now, we're pretty good at this point, and then what will mess students up is this next part. And I'll give you some keys, okay? Listen. I'll give you some keys. There was only one person that got it right last period, but there was one person that got it right. Okay? I'm going to give you some keys. All right? So, first key. When you look at the periodic table, that periodic table is your guide. No, you already have it. Hey, listen. So, when you're in this, you're filling this section, and you're filling what sublevel?
The one
S. You're excluding helium. If you're in this one, what are you filling?
P.
P's. If you're here, you're filling
D's.
and here's the. Okay?
Why'd
That's-
you cut off the top part of that? Because that's still in.
Okay, so that's one little hint I'm going to give you, all right, to do this one. So that's really the only hint I'll give you. So which one I want you to do is I want you to do calcium.
Calcium.
So do calcium. Calcium's element number 20. Go ahead and write the electron configuration for calcium. Ca. So these two electrons, these two electrons, they have to pick somewhere to go. So these two electrons are like, where do we go?
Me anywhere.
Do we go the first level? And the answer is no. Why? It's full.
Phil.
Okay? Can it go to the second level? Nope. Full. Can it go to the third level?
Yes.
Okay, so these electrons, you say, hey, they could go to the third level, and if that's the case, these are what? They're not P's.
They're D's.
D what?
D2.
D2. Okay,
Oh my gosh, I had it right.
that's one possible
Is that the right or wrong?
answer.
So that would be right or
Okay?
Or wrong.
That's wrong.
Don't leave me a choice.
Can you bring them
So
back
is
to
that a
S's?
possible right or wrong answer?
Oh, but the electrons don't go to the next thing.
Hey,
I get it.
now, that's one choice. The other bit of information I gave you is like, okay, he said that this block are S's. And he said that these will end in S's because they're in that block. And when we look at elements in that block, we have, for example, beryllium. Beryllium is in the same column as calcium, right? Okay, it had 2 here, and those were S2s. All right, calcium, and I didn't show one earlier, but the choice is, well, according to that, they should go to an S, and are the S's full in the third level?
Yes.
So where could they go if they went to
Next
an S?
level, so
They could go
fourth
here.
I had it either way. I had it right.
That's the wrong one. We gonna have a test over this?
Listen. So it's like, okay, the 3D2, what's the difference between, why do the electrons choose one way over the other? Okay? And so this is a bit of information you don't know, is that if you had an energy chart, okay? This energy chart was going up, and then when you go up this energy chart, it starts out at 1s2, and then that one fills, and then your next part of the energy chart is a 2s, and then you have a 2p that's a little higher in energy, okay? And then you got a 3s that's a little bit higher than a 2p. And then you have a 3p here, it's a little bit higher, okay? And then you've got a choice for it to go to a 3D over here, or to a 4s on the chart, which one is it going to go to?
Probably the 4s.
So this is less energy, just a little bit, compared to that 3D. So guess where the electron chooses, because it's lazy, it always wants to go to the lowest energy level. It's always going to go to the 4s. Now, okay, here's the deal. That's the problem students will have, is they will not be able to do this next one because they want to fill that 3D. They're not satisfied with the D not filling completely, and they feel like they need to fill that D's before the fourth energy level starts. And that's the people that thought along this way, which was okay up to this point. Now you got to think, all right, I'm an electron, and I got this energy chart. The 4s is lower than the 3D, so it goes to the 4s. Okay?
I remember like last year,
Okay, go ahead.
Because electrons are lazy, the D sublevel does not need to be full because it will most likely go to the fourth level.
The D will eventually fill, Raquel, but it will fill in a way that it has to wait its turn. It has to wait its turn because of energy. So when we fill out the 1s first, then the 2s, then the 2p, and the 3s, and 3p. The 4s has to fill, so what comes next? Where are you at when you start filling after calcium? Where are you at? What sublevel is this?
D.
D's. What level of D's?
3.
3s. They start to fill now. They fill after the 4s. Okay? So, last one I'm going to have you do. You're going to do manganese and start at the beginning and do the electron configuration for manganese.
Great. I love that.
Do manganese. 25, element 25.
Is this another tricky one?
Kinda, yep.
If this is another tricky one, I'm question number 25.
This is the one that students mess up past this point. They're pretty good through argon, and then once you get argon, they forget some of the rules.
So it's manganese, not
You got to memorize manganese.
and it goes S, D,
There can be 10.
or SPDF. SPDF.
SPDF.
SPDF.
SPD.
SPD. I'll remember that.
Okay.
SPD.
Sounds like
Let's see if you can follow along with the guide. Where are we at on your guide?
1s, 2, 2s,
Where are we at right now?
Oh, we're on the
Helium.
D block.
Helium.
Two.
Nice.
Where are we at?
Barium.
2p6.
Helium.
Beryllium, right?
Yeah, barium.
Yeah. Yeah, would that be 2s though?
Oh, I'm sorry. There's been 2s. Okay, 2p6. Where are we at?
Neon.
Neon.
3s2.
Neon. Wait.
Guys, it's,
Wait, too fast.
We're on neon right now.
we're at neon. Okay? Where are we at?
Magnesium.
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 Oh, I see.
Now we're on.
Argon.
Where are we at?
No, we're not.
No, where are we at?
Phosphorus.
Phosphorus.
There you go. We're at phosphorus. That's the electron configuration for phosphorus.
Boom.
You
Okay?
can like just cut the number in half different things like for fun.
Oh, okay.
What's that one?
Argon.
Argon. Where are we at?
So now we're on
Oh, it has to fill
Potassium.
It has to fill all that.
Okay?
We have to go to D.
Where are we at now?
Calcium.
Okay? We'll go through the D's. How many D's do we go through?
5.
Because it has to have 7 covalent electrons.
Right?
Yeah.
You count over. 1, 2, 3, 4, 5. We're at manganese. We count over 5. What is this number?
It's P3.
3.
Wait.
Right?
But why is it 3?
Because the 3 D's have not been filled yet.
I have.
That's what I was gonna ask. How is it not
If you go to 4 D's, you're skipping over the 3 D's. Which one has lower energy, 3D or 4D?
3D.
3 D's.
I just put 4P.
They have to go to fill up. Now they'll fill up that whole level. So if we go if we go 3D10, where we at?
4s2.
No, where we at?
So now we're on.
Oh, 4Ds.
We're at, yeah, 3D10, where we at?
4Ps.
Zinc.
Oh, yeah.
Okay,
Wait, it's supposed to be 3D10?
no.
No, she's just going over different examples of what the things would be.
I thought that,
Wait, so why couldn't you just put 3D10 and then 4s2?
Why is there 4 before 3?
Because which one's lower energy?
Is less energy.
Grace, which one's lower energy?
3D does.
3 gold stars is
Would it be 3D? Or would it be 4s? No,
4S.
it's 4s. It's 4s.
No, that's not.
Yeah.
Okay, so this, this element here is zinc.
alright, should we add P at the end of the manganese?
Okay, now, you guys have an assignment for tomorrow.
Oh, lovely.
Yep. You guys got to give me the configuration for carbon.
Okay.
I may be the most confused man alive.
Carbon.
Before you leave, these 4, silicon,
Okay.
iron,
Iron. Fe.
and
Give us a good one.
let's go with, this is a tough one, but I think you guys can do it. Arsenic.
Ah, I love arsenic. Tasty.
I'm the most confused man.
Okay, electron configurations for those 4. No, you don't have to do the drawing of the orbitals. You just have to do the electron configuration.
Darling, I'm confused because I believe in manganese.
Simon almost.
No, that's not.